which are a little bit more just, education oriented. What is Renai, what is the technology. But Ken Mitchell, I mean, you're well entrenched with installers doing, tear down, taking the units apart, reinstalling them, going through troubleshooting. We like to have our training out there right in the field so we can teach people based on, how things are in Saskatchewan versus, how things are in Ontario or BC. Different issues. We also deal with authorized service providers, so a lot of the dealers that we have, we like to have them trained annually. We like to have them up to date on the latest technology, what's new that's coming, what changes that are out there. We like to keep them apprised at all times. It's very important for us. Skip over that. I mentioned that I talked about condensing versus non-condensing, and Ken will probably chime in a little bit more on the subtle differences between the two. But why is condensing such a game changer? Like as I mentioned earlier. And here's my chalkboard to make up, because I can't write on your beautiful television up here. So what is a condensing unit? With heating water, I mean, you basically want to get as much heat from the flame into the water. I mean, that's the goal. That's your efficiency. So basically, the more of that transfer that you can do is going to affect that EF factor, that energy factor that you have. It's kind of like a vehicle's miles per gallon measurement. Leftover heat that doesn't that is not absorbed or is not transferred, your heat transfer, it's going right out your flue. So and that's what the fundamental difference is between the two, between condensing versus non-condensing. In a non-condensing unit, you basically have a single heat exchanger. The water heater is going to transfer about 83% of the heat into the water. That's still well above the average tank. Tank efficiency is about 60%, so it's still much more efficient. But it's about 83%, so that's 17%. That's going up the flue and outside. Start getting into condensing water heater. It has a specially designed heat transfer. It's basically a second heat exchanger on the device. And it's designed to transfer almost all of the heat to the water. When it does that, by having a secondary heat exchanger, the exhaust temperature is going to drop drastically by doing that because of that, the flue gas. It's to the point where moisture is going to begin to condense from the exhaust, and so the unit is built in, so it has a condensation collector built into it. But now you start looking at, in terms of efficiency, you're going to look at efficiencies of about 95% by having this extra feature built into it. So you're not wasting that much energy up through the flue. So there's a big difference by having this minor design change on the device. Thermal efficiency, because we keep dancing around that. What percentage, how much fuel is actually transferred to the heat? And we're going to look at some examples of the various products, tanks versus tankless. So if you take an average gas tank, the tank water heater with a max input BTU of 36,000 and a thermal efficiency of 60%, which we talked about, thermal efficiencies, it can transfer 21,600 BTUs into the water. That's what your average gas tank's going to do. If you look at a Renai non-condensing tankless unit with maximum input BTU of 199,000, it has a thermal efficiency of 83%, it can transfer 166,000 BTU into the water. So it put that much more into the water. So looking at the condensing unit now, this other unit, which is at a thermal efficiency of about 97%, the same unit at 199,000 BTU input can transfer 193,030 BTU into the water. So it's very significant what this technology can do in terms of your heat transfer. EF rating, energy factor. Let's compare all of the units again. If we look at all of the energy used, including electricity, and we're going to use those three products again, an average electric tank has an energy factor of about 0.98. Exactly. But let me finish because there's again, with comparing efficiencies, you have to look at first cost versus monthly costs and average it all out, which is very important so you get the full picture, pros and cons. Average gas tank water heater has an energy factor of about 0.62, which we mentioned. Get into the Renai, the non-condensing unit, the energy factor is about 0.82. I'm saying approximately, it's give or take, 0.1, 0.2. Get into condensing, you're looking at an energy factor rating of about 0.96. All right, so why is the electric tank so efficient? Good question. But the other side of that is, how can it be efficient when you're constantly reheating that water? You constantly have to reheat that water. So why is that not factored into this? Well, the next couple of slides we'll talk about that. Looking at the monthly fuel cost. And again, we're going to have to use a little bit of American data here, unfortunately, just because that's all I had at the time. And I'm working on getting it Canadianized, if you will. So cost of usage versus the first cost, looking at the cost of usage. And now we'll look a little bit more specifically at that electric tank. An electric tank water heater versus a gas tank water heater, natural gas. An RL75, a non-condensing tankless unit. And a condensing tankless unit, natural gas again. So if you look at the energy factor and plug all those numbers in, there's that high number for the electric tank water heater, 0.98. 0.62, 0.82, and 0.96 on the condensing tankless water heater. Whether it's kilowatts or BTUs per year, we plug those numbers in. And this is based on an average home using, what was the number that you mentioned earlier for usage? This is based on
liters per person?
300 liters per person.
Liters. Yeah.
Is that accurate? Is that?
Yeah,
It's a Canadian average.
Is it?
Yeah.
Yeah. My 3 girls in my house, it's all right. So we punch those numbers in for the various products. If we look at therms per year, and again this is using Department of Energy averages based on 2009, and we plug those numbers in for each unit. And we take the 2011 average cost per therm or kilowatt hour. In this particular case for electricity we're using basically 12 cents a kilowatt hour. I'm not sure what the rate is.
What our rate? That's our rate. We're 11.4.
Oh, that's good. Yeah, we're close to 14 cents.
Yeah.
You and I in Ontario. Cost per therm for the gas tank, punch the same in, and then we average that all out so we can see what it is monthly, and then look at it annually, and you see that an electric tank water heater is about $522. The gas tank water heater is $266, it's about half. Get into the non-condensing tankless unit, it's $201 annually. And the condensing tankless unit is $177 annually. So that's now you're looking at both sides, the first cost versus the monthly, what it costs to run the unit. And so there's substantial savings there when you're looking at condensing, which is why it is that game changer, as I mentioned. It's 66% less than the electric tank. It's 33% less than a gas tank, which is the most commonly installed product in Canada, but by far. It's even 12% improvement over non-condensing. So that's my chalkboard. I have another one.
Sorry, can you go back to that?
Absolutely. Yeah, please.
So the difference in the difference between the gas tank heater and the electric tank heater is because of the cost of energy. Is that fair?
Yes.
It's just a different cost of energy because one's 50% more efficient, but electricity's
Because of the cost of
Yeah.
what we're paying
The
for.
electric tank doesn't have a flue, so you're not losing
You're not losing as
of the
much
flue.
energy, but you're paying more for the energy you use.
Yes.
That's right.
We lose that flue over in Esteban or wherever the
Yeah, where.
generator.
Okay.
Okay, so I understand that. And then the difference between the gas tank heater at 62 and the condensing tankless heater at 96 is that we're not storing the hot water? Is that the difference? Like, why is the difference between
We were
those two?
recirculating the flue gases, okay, to bring
the
out
condensing.
that addition, in the condensing, okay, as opposed to sending on 0.82, instead of sending that up the chimney, all right, we're taking a secondary heat exchanger in the condensing water heater, so we're making that much more efficient. So we're taking that additional flue gas temperatures and we're recirculating it back down into the hot water.
So that's the difference between the 201 and the 177?
Yes.
What's the difference between the 201 and the 266? That's heating the stored water? keeping that off, is that what causes that?
That's heating stored water and also flue loss.
Flue loss,
And flue loss.
yeah.
But there's flue loss in a non-condensing tankless as well, isn't there?
Yes, there
Yes.
is.
So the difference between 266 and 201 must be the storage
Now,
level.
hold on, when you say there's flue loss in the non-condensing, there is only when the unit's running.
On
If you
both of them.
picture a tank
Yeah,
where
on
heat
both
is
of them.
radiating off and going up the flue just by fact of hot air is going up the flue. On the non-condensing or an eye, the only reason you have flue loss is because you don't have a secondary heat exchanger. There's no standing pilot, there's no hot water sitting in that unit.
That's right, that's a good point.
So there is no standing flue loss in a tankless water heater.
Yeah, it's on demand.
Yeah.
Any other questions on that? I know the chalk, what's
Does
the
that make sense?
chalkboard?
It does, and I'm trying to figure out in my head what impact the preheated water would have to these numbers. Like,
That's-
we'd have-
yeah.
That'd be an interesting
That would be
calculation.
very interesting
On
to
your
calculate.
system?
Yeah,
Like, we'll have preheated water from the solar thermal. That tank will be probably 120.
Okay, so you can probably take that 0.82 and, on the non-condensing and maybe put that up about another 2 percentage points, 3 percentage points. Because it's not like the standing 0.62 in the conventional gas hot water,
Hmm.
where you are losing that water that's standing, sitting in that hot water, that's 60 gallons or 30 gallons.
You're still gonna have flue loss on that one.
Yeah,
yeah.
yeah.
Now, would
But on your point, where you've already got that standing tank, you can probably put another 2 or 3 percentage points on that, on the non-condensing. That's a good idea.
So would you have to look at the average? How
Yeah.
would we do that?
You'd
We'd have to look at the average.
But it would bring down your